Hello, I'm Mridula, and this is my lab video 2 for Physics 2111, Motion of a Falling Object. The purpose of this lab video is to observe the motion of an object dropped from rest and the forces such as gravitational force and drag force acting on the object. Then to compare the observed model versus the two computational models, one without drag force and one with drag force. A preview of the main result is that the computational model with the drag force represents the motion of the falling object more accurately than the computational model without drag force. The principles used in this video are Newton's second law of motion, which states that the rate of change of momentum of a body over time is directly proportional to the force applied. Net force is equal to mass times acceleration, which is equal to the change in momentum divided by change in time. Force of gravity is equal to the gravitational constant times m1 divided by r squared, which equals 9.8 meter per second square. The drag force is equal to negative b times the magnitude of vector square into v hat, where b is the proportionality constant. If there's no drag force acting, then the net force is equal to the force of gravity. The velocity update formula is final velocity equal to initial velocity plus net force divided by mass into delta t. The position update formula is final position equal to initial position plus average velocity times delta t. The system is a complete paper ball, surroundings is everything else. The initial position is 0.124 in the y-axis, initial velocity is 0 and the mass is 3 grams. So here I used a tracker to track the motion of the paper ball falling. So I manually tracked each frame of the paper ball falling, and I used a calibration stick and both the axes. So on the right side, you see the y versus t graph. So as the paper ball is being dropped, it goes farther and farther down the negative y-axis. The total time taken was 0.733 seconds, and when I calculated the average velocity, I got negative 0.33 meter per second. So this is the experimental data or the experimental model. This is my gyroscope code. So these are the initial conditions for the computational model with and without drag force. So the mass of the paper ball is 3 grams. The position of the paper ball is 0.124 in the y-axis. Velocity is 0 as the paper ball is being dropped from rest, and time starts from 0, and delta t is 0.033, which is the time step I got from the tracker. G is 9.81, and of course j hat is 0, 1, 0. On the left hand side is my code without drag force and only gravity. So b is equal to 0 as there's no drag force, and t is less than 0.73 as that was the total time taken. And next is W, or the force of gravity, is equal to negative mass of the ball times G times J hat, and the net force is equal to only the force of gravity as we're not taking drag force into account. And then next is the velocity update formula and the position update formula to update both the velocity and position. On the right hand side is my gyroscope code with the drag force. So b is equal to 0.0013, which I calculated, and inside the while loop, the force of gravity is the same formula as we saw before, and then the drag force formula is b times the square of the magnitude of the ball's velocity times j hat, and then the net force is equal to the force of gravity times the drag force, and then we again use the velocity and position update formulas to update both the position and velocity. This graph here has all three models plotted. So the green line is the observed model found using a tracker, the orange line is the computational model without drag force and only gravity, and the blue line is the computational model with both gravity and drag force. So as you can see here, the computational model with the drag force, which is the blue line, is more closer to the observed model, which is the green line. So this shows that the computational model with the drag force and gravity, it accurately represents the motion of a falling object. The possible sources of error are the tracking error, where the placement of the point of mass may not have always been at the center of mass of object, and the initial force applied when dropping the object. The computational model with gravity and drag force has terminal velocity, and the gravity and drag force will cancel each other out, so the net force will be equal to 0. For the second question, the terminal velocity in both the cases would be the same, as it does not depend on initial velocity. Thank you for watching.